Okay, here's our 7.1 lesson. It should be pretty short. Today we only have got 2 examples to do, and only one of them is new. Okay, so we're talking about modeling linear relationships. That's just a keyword for you to know that we're going to be talking about word problems, which you already know. This first one is one that you should already know how to do. They're asking me to write an equation for the problem. So what I want you to do now is pause the video and try to write an equation for this scenario given right here. So pause the video and try to write that on your own. Okay, now that you've had a second to try that, let's see what you got. If you're looking at important information, it says each transaction is worth 12 points, and customers automatically earn 25 points when they sign up. So 25 points when they sign up. Some things should stand out to you. First of all, when they sign up, that's at the beginning or the start, and that should make you think that we're talking about our y-intercept. And then this says each transaction, which is a key word for slope. So if you're writing your equation, you should have y equals 12x plus 25. Okay, and the only other thing that we need to do is just talk about our variables. So x here, if you read the problem, it says 12 each transaction. That means this is 12 points. So x means the number of transactions. It's important for you to know what that stands for. A transaction is like how many times you're purchasing something. And then y, well, this whole thing, if I say I want to have, I don't know, however many transactions, 5, 10, whatever number I'm plugging in, whatever I get when I plug that in is my total number of points. So y is going to be my points earned. And you want to write this every time, that's what y stands for. Y is going to stand for my points earned. And the last thing, and we'll touch on this a little bit more tomorrow when we start to graph these, but this is an example of a discrete scenario, because if we think about our x values, we want to ask ourselves, can we plug in any number there, and that includes decimals, or can it only be whole numbers? And because this can only be whole numbers, you can't have like half of a transaction. You can't halfway check out at a store, right? So because you have to have a whole number of transactions, it's going to be discrete, right? We can only do specific points. We can't talk about the numbers in between. So let's look at a different type of word problem. Take a second to read this, and you are probably going to need to copy down some of the important parts. So read this, and let's just make some bullet points of what stands out to you. So pause the video and think about what's important. All right, and now that you've thought, we just need to make some notes. First of all, it says the band director has asked the club to raise at least $1,000. Now we're going to talk about that, but when you read down here a little bit more, it says we want to meet their goal. So that means exactly $1,000. So the first thing that you need to write down for this example, so that you don't have to write the whole word problem, the first thing you need to write down is that they want to meet their goal of $1,000. All right, it says t-shirts cost $10 each. So I'm going to write that down. T-shirts are $10 each. Oh, I should probably put the amount in there, $10 each. And then blanket wraps cost $25 each. So blankets are $25 each. Now, some things should stand out to you. First of all, I've got each in 2 different places. That means that both of these have variables. These both have variables. So you may say, does that mean it has 2 different slopes? Well, not when we go to graph it, but in the equation, it's going to look kind of like that. Also, here they give me the total. So I want you to recognize that what we're about to write is an equation that is going to be in standard form, which means it's going to be ax plus by equals c. Now, we may use different letters for the X and the Y and different numbers, but just kind of recognize how this is going to be set up. I'm going to erase that. Okay, t-shirts, a variable that makes sense for t-shirts is the letter T. So I'm going to say T is the number of t-shirts sold. My number of t-shirts, I cannot spell today, sold. And then B, that kind of makes sense for blankets. So B is going to be my number of blankets sold. And when we put these together, my equation is going to be, there are $10 for every t-shirt, so that's going to be 10T. If you're writing lowercase, you may want to put a little tail on your T so it doesn't look like a plus sign. All right, blankets are $25 each, so I can also talk about my blankets, 25B, and the total that I want to get is 1,000. All right, so notice now my equation is written in standard form. So we're going to think about this equation. We're going to use a graph to be able to answer the final question, which is how can they meet that goal? So here's my equation. Make sure you understand where I got all those pieces from. And let's look at the graph. All right, so my graph, we got to pick different things. They're telling me T goes on the bottom. Okay, so I just copied our equation over. T goes on the bottom, which is the number of t-shirts. On B, see, they've already labeled that for me. B is for the number of blankets. And I just want to talk about how to graph this. So in standard form, I could solve and get this in y equals mx plus b, but the easiest thing is to give my two options where we do the cover-up method. Okay, so I'm going to assume that I haven't sold any blankets first. So if I make a note of that, if I don't sell any blankets, I put in 0 here for the B, that whole part goes away, which means I'm going to give myself the equation 10T equals 1,000. So if I don't sell any blankets and I divide that out, that means I have to sell 100 t-shirts. So that's 1 point is going to be 100, 0, because I plugged in 0 for the blankets or the B value. Okay, my other option then is to assume that maybe I don't sell any t-shirts. So we're doing our cover-up method, and now we have 25B equals 1,000. Well, if I divide that out, I'm going to get that I'm going to have to sell 40 blankets. If I write that as an ordered pair, that gives me 0 t-shirts and 40 blankets. All right, so to graph this, it's really easy. 100, 0, that's down here on my T. That's 100 t-shirts and 40 blankets. And for the sake of ease, we're going to connect these, but know that they really shouldn't be completely connected. So we're going to connect these, and there we go. That's going to be our graph. And now they want us to find maybe another solution. So we could sell all t-shirts or all blankets, but think about another combination. We'll define that. We can try to see maybe where it's crossing somewhere in between. And it looks like maybe right here, and we'll talk about how to check this tomorrow, maybe if we sold 50 shirts and 20 blankets, that would get us to our goal. And you could check that by plugging in or thinking about the cost of each and see, does that give us 1,000? So check that on your own and see, is that a solution? And you should be getting that yes, when you multiply that, you do get $1,000. So yes, that is a solution. So that ends up what we've got here. I just want you to kind of think about that. Think about that problem and go back and rewatch it if you need to. And let's look at our lesson questions. So be able to answer these questions before you come into class tomorrow. If you cannot answer these questions, then you need to rewatch the video, or at least enough to be able to answer those, because that's what you need to know coming in here tomorrow.